Okay, for number 8, okay, again, the first thing you want to do is draw your heating curve of water. Now remember, we said that water has 3 different heat capacities depending on what state it's in. Ice has a heat capacity, liquid water has a heat capacity, steam has a heat capacity. Okay? What we have to consider is, where do I use each one? Well, if this here is at 0 degrees Celsius and this is 100 degrees Celsius, then here water is in what state? Liquid. Here water is in what state? Ice. Up here water is vapor. Okay? So we have to know above 100 degrees, I'm not using 4.2 as my specific heat capacity anymore. I'm using 2.02 because that's the heat capacity of steam, and water is steam above 100 degrees. Everyone follow on that? Okay, so for number 8, okay, we'll simplify here. For number 8, I will have, I think, 3 steps. So there's my heating curve. It says I'm starting with ice at minus 10 degrees, and I'm going to water at 80. All right, so here's where I'm starting, and here's where I'm finishing. That means I have 3 steps. I will have this step here, where I will use E equals mc delta T to heat the ice by 10 degrees. Then I will melt the ice, E equals mLF, and then I will heat the water, E equals mc delta T. Everybody with me so far? Okay, so down here in step 1, okay, this E equals mc delta T is going to be, so it's 0.05 kilograms, that's 50 grams. Okay, 50 grams times the heat capacity of ice, 2.116, times the change in temperature. I'm going from minus 10 to what? 0. All right, because it's only going to be ice until I get to 0. So that's 10 degrees Celsius. Okay, so 50 times 2.116 times 10. All right, 1,058 joules. All right, the second part here, E equals mLF. I'll do it over here so I have room. E equals mLF, my 50 grams times the latent heat of fusion, 333 joules per gram. All right, is 16,650 joules. Okay, everybody with me so far? And now I have liquid water at 0 degrees Celsius. I need to heat it to 80, so I'm going to do my E equals mc delta T. 50 grams times the heat capacity of water now, 4.2, times 80 degrees Celsius. Okay, 16,800 joules. All right, so now I figured out how much energy is involved in each step. Can I figure out the total energy? Yeah, I add those 3 numbers together, and I get 34,508 joules. Okay, does that sort of make sense? All right, like I said, the biggest thing is making sure you use the right heat capacity. That tends to be the biggest stumbling block for people. All right, if you're between 0 and 100, use 4.2. If you're below 0, use 2.116. If you're above 100, it's 2.02. Okay. All right, any ones we want to go over? Those will definitely be on the test, yeah. Okay. Any ones in particular you want to go over, guys? Don't be afraid to ask. Okay. Okay, so for number 10, okay, our mass is 150 grams, and we have steam at 130, and we're cooling it down, condensing and cooling it down to 30 degrees Celsius. Okay, so again, draw quickly our heating curve here. We're starting way up top this time, and we're going down to 30 degrees. So that is cool the steam, condense the steam, cool the water. How many steps? 3. All right. This step here involves a temperature change. So step 1 will be an E equals mc delta T problem. Okay. Step 2. What formula do we use for that? E equals mLV. All right. And step 3, I'm reducing the temperature of the water. So that is E equals mc delta T. All right, so for step 1, okay, we have 150 grams, so 150 times the specific heat of steam, 2.02, and I'm changing the temperature there by 30 degrees. Okay, so 150 times 2.02 times 30. Now, if you really wanted to, you could make that temperature change negative, because in reality, it is. So your energy will come out negative. And that's fine, because are you losing energy in this problem? Yeah. Okay. Either way is fine, though. If at the end you have a positive number and you write lost this much, I'm fine with that. Okay. You understood that it was losing the energy in order to do this. Okay. 9,090 joules for the first part. Okay, for step 2, we have our 150 grams times 2,260 joules per gram. Okay, to find out how much energy will be released when this stuff condenses. All right, and that's 339,000 joules. Okay, and then we have to cool the water. Okay, so in cooling the water, I still have 150 grams, but now what specific heat capacity do I use? Water. So now I have to use 4.2. And my temperature change from 100 to 30 is how many degrees? 70. Okay, so 150 times 4.2 times 70. All right, 44,100 joules. Okay, when we add those together, we should get 392,190 joules. Okay, and that would be lost, okay, or negative, whichever way. Any others? Okay, keep going, guys. They're all pretty much the same.